Welcome to a proof of the consecutive interior angles converse, sometimes called the same side interior angles converse. This theorem states that if two lines are cut by a transversal and the consecutive interior angles are supplementary, then the lines are parallel. So this is saying if angle 3 and angle 5 are supplementary, then the lines would be parallel, or if angles 4 and 6 are supplementary, then the lines would be parallel. Let's go ahead and set up a two-column proof for this theorem. So we're given that transversal T cuts line L and line M with angle 3 and angle 5 supplementary. So these two angles here are supplementary. So let's talk about our strategy before we begin. We just proved the alternate interior angles converse, which states that if angles 3 and 6 are congruent, the lines would be parallel, or if angles 4 and 5 are congruent, the lines would be parallel. So if angle 3 and angle 5 are supplementary, and if angle 5 and 6 are also supplementary, because they form a linear pair, we stated earlier that if two angles are supplementary to the same angle, then they must be congruent. So angle 3 and angle 6 are both supplementary with angle 5, and therefore they would be congruent. So that's the outline of our proof. So step 1, we'll go ahead and state the given. T cuts L and M, and angle 3 and angle 5 are supplementary. And we can also say that angle 5 and angle 6 are supplementary by definition of a linear pair of angles. And this is all we need to state that angle 3 and angle 5 are congruent. If angle 3 and angle 5 are supplementary, and angle 5 is also supplementary to angle 6, angle 3 and angle 6 must be congruent. And the reason for this is that angles that are supplementary with the same angle are congruent. And this should have been reason 3 here. So now that we have angle 3 and angle 6 congruent, notice they are alternate interior angles, and we just proved the alternate interior angles converse, which states that if these angles are congruent, the lines must be parallel. So line L is parallel to line M by the alternate interior angles converse. And that'll do it for this proof. I hope you found it helpful.